In the emergency room, time is the absolute scarcest resource. From the second a patient arrives, the clock works against the medical staff. Doctors and nurses execute a highly physical, coordinated routine. But parallel to their movement is an invisible process, the urgent digital request for the patient's medical history from an external clinic. If we freeze time at the exact moment a critical intervention is required, we isolate a specific decision event. In this exact millisecond, the greatest risk to the patient is not a lack of medical expertise. The risk is the fragmented, incompatible data systems the attending physician must rely on to make their choice. This diagram reveals the hidden digital architecture of a typical hospital. Notice the nodes flashing red. These represent failed connections. These overflowing nodes illustrate a paradox. Institutions possess massive operational data, but lack a verifiable trust system. When these systems fail to communicate, the real-world consequences are immediate. Patient routing is delayed, handoffs between clinics are compromised, and administrators face slow, manual checks. To fix this, institutions require a highly engineered approach. They need mathematically guaranteed value extracted directly from their operations, rather than simply accumulating more unstructured files. Relying on unverified data creates administrative delays that directly impact patient care. Systems must be built on cryptographic auditability, meaning every single action is recorded with a mathematically proven, tamper-proof signature. Addressing this exact vulnerability requires targeted infrastructure. Oracle On-Chain and its founder, Pixelgod, developed a solution by combining a 10-year legacy in blockchain engineering with 7 years of applied AI development. This animation shows the core of their solution, the Unified Model Context Protocol, or MCP, server. The MCP acts as a universal gateway that allows artificial intelligence to interact with any network securely, turning raw data into structured streams. We call this the value extraction layer. It uses specific on-chain and off-chain intelligence modules to actively filter out operational noise and pull forward actionable insights. The architecture operates as a dual engine. The AI system is designed to analyze and optimize the workflow, while the underlying blockchain network is designed to secure the transaction. By merging autonomous AI with immutable ledgers, databases where entries cannot be altered or deleted once written, hospitals finally have a system engineered to withstand the extreme vulnerabilities of modern networks. Returning to our frozen decision event, this visualization traces the patient's critical file as a stylized packet shooting through the MCP infrastructure in real time. In a fraction of a second, the AI scans the incoming operational data, evaluating hospital resources to instantly predict the best care route and optimize the clinical workflow. As this diagram illustrates, while the AI routes the care, the decentralized node network locks a cryptographic hash code onto the data packet, signing the action to ensure absolute privacy and security. Because the action is signed simultaneously, the protocol generates a tamper-resistant audit trail for the entire decision event. The attending physician receives perfect, verified operational intelligence instantly. A highly complex, fragmented data request is resolved in milliseconds, enabling a coordinated medical success. This view demonstrates how the technology scales. Pulling back from a single emergency room, we see a regional healthcare ecosystem connected by verifiable infrastructure. Because the MCP suite is fully modular, institutions do not have to rip out and replace their existing databases to begin extracting value. As the vector icons lock into the map, we see specific deployments like biotech privacy nodes for secure medical records and specialized tracking modules for clinical trials. Clinics and digital health providers can adopt these individual components to target immediate bottlenecks, or they can deploy the full decentralized stack. This modular approach ensures that entirely different institutions can exchange data securely and reliably, maintaining strict compliance without sacrificing operational speed. The contrast is clear. The high-risk, siloed operations of the past are replaced by a system of automated, trusted intelligence when using this specific architecture. This infrastructure establishes the mission-critical environment required to elevate operational efficiency and protect human life. By deploying native on-chain intelligence, healthcare providers can mathematically guarantee the accuracy of every decision. Oracle On-Chain, the unified infrastructure for decentralized intelligence.